doing a second attempt here just because I did make one major mistake and just kind of got under my skin, and it happened kind of early, so I just thought I would address it early. Okay, so part A, again, hopefully you've read through this question, you've tried it out. That is kind of the way you should be going through these, and you're just kind of looking to see what I did. And so here's the thing, when I first looked at this question, I said, okay, cool, 95% confidence interval, and I did write out the, I'll show you my work here, I did write out the point estimate. I showed the z-value, I showed how I got the standard deviation, and I showed how I made my interval. But it turns out that any time you use an interval or a test, you need to first state the conditions of that interval or test. So we'll use a one sample z interval, and I guess I'll write what that is. That's actually I'll use, not say one sample, it is one sample, but one proportion z interval, and that's p hat plus or minus your critical z value times the standard deviation, which is given by this. And this is all in the reference sheet. Now from there, here is the idea. We need to show the conditions have been met. Stated we were I guess I'll say this. Stated data was obtained from a random sample. That's a super important condition. And the second condition they care about is that there were 23 successes. And let's hear, well, if we sampled 80 and there were 23 successes, that means there were 57 failures. So our distribution is, I guess I should say our sample distribution. I'm talking about the sample here from the 23. Our sample distribution is approximately normal. Okay, now those were the two conditions they wanted up front, so I just thought I would start the video off by at least going through those two things. All right, now from there, let's compute the interval. Well, p hat is just our 23 over 80, which is 0.2875. Now our critical z value, so z for 95%, you can look at the bottom of the t table. The bottom of the t table has z value, so 1.96. And then the standard deviation is going to be the 0.2875 times 1 minus that, which ends up being 0.7125, all divided by our sample size of 80. And so let's calculate that. Square root of 0.22875 times 0.7125 divided by 80, and we get that. The standard deviation is 0.0506. Okay. So I'll say, so the 95% CI is, and so we have 0.2875 plus or minus 1.96 times 0.0506. You could stop right there, but what I'm going to do is I'm actually going to write this out as the correct interval. Say or. So get the 0.2875 times 1.96 times 0.0506. That's the, whoops, I wrote times. minus. This is the lower bound, so we get 0.1883. And then we need the upper bound, which is 0.3867. Okay, and that is the end of part 1. So, actually no it's not, because we've constructed the interval. Make sure you go back and, always go back, read the question, ask if you answered it, ask if you have more time to put more in there. But they say construct, which I did, and interpret. Okay, so maybe you might want to put like a little line for interpretation or something, but we are 95% confident. And if you want the best interpretation, it's right there in the question, so just read the last part of part A. We're 95% confident the true proportion, you should spell that all out, of customers who order a water cup but fill it with soda is between 0.1883 and 0.3867. And there you go. So again, let me just go to the scoring guideline now. Part A, again, this is the part that I missed the first time around. I totally forgot to check the conditions. I just went right into forming the confidence interval. But key thing I learned today was when you form an interval or you do a test, state the conditions of the test and that you've met them. All right? Now from there, I formed the interval correctly. I got the correct responses, and then I also interpreted it correctly. Right? And so also always break down the scoring section. You can see essentially section 1 were those conditions. Now honestly, I got an incorrect because I just skipped over it completely. Section 2, I got an E the first time around. I know I did the interval correctly. And then also part 3, I said it's an inference of population proportion, so I said the true proportion that goes along to the idea that it's the population. I could have said the word population though, that would have helped. Demonstrates an understanding that it's about the proportion of water cup population that fill the cup with a soda drink, and I mentioned with 95% confidence. So, I mean, again, it's pretty easy to get part 3 or that interpretation correct because, essentially you're just restating what they asked you to find right here. You're just using this exact wording and just attaching your values that you found at the very end of it. So it's actually really easy to get that point. Okay, part B. So part B is a little bit easier. Now again, there's something I said last time that shows up here that you want to take note of, and that is if you're going to do anything in the calculator, put it on the page as well. So since we are 95% that the population, I guess I'll spell it out, population proportion of customers who order water cups but fill them with soda is between 0.1883 and 0.3867, for 3,000 customers who order water, I should say, order water. I'm going to write it like this: 3,000 times 0.1883 equals. So again, if you're going to need the calculator, write that down. Now also, I'm going to round this one up. There's actually a specific reason why, and I'll tell you why in a second. So I'll say that to 3,000 times 0.3867, which is 867. That's going to round down. Of those will fill a cup with soda. All right, now in other words, here's what I'm doing. I'm just showing how many customers out of the 3,000 based on my interval. So again, that's the low proportion of the 3,000. That's the high proportion of the 3,000. So if you scale that to the 3,000, anywhere from 565 customers to 1,160 of the 3,000 will order a water cup and fill it with soda. Again, after that, we're almost done. It's actually not a lot of math here. I'm just having to do a lot of writing to explain what I'm doing. So then, since this costs, I guess I'll say per customer, we expect the true cost to the business to be between, now again, I'm going to show the math here, 65 times 0.25, which is $141. And 1160 times 0.25, which is 290. And I'll say for the month of June, because this isn't all time. This is just for a specific amount. Okay. So again, I mean, hopefully when you look back at this, if you were able to calculate the correct interval, then the remaining work there is actually not too difficult. It's really just two multiplications, scaling this to the 3,000, and then scaling the amount of people to the cost per person, and then you're pretty much done. But you definitely want to explain why all this makes sense. That's the big part of statistics, is giving an explanation for all that you do. So 30 seconds to check the scoring guideline. Okay. So do I give a correct interval estimate and show enough work to indicate how the interval was found? So that's what I'm doing here with all of that extra talk. So part B, using the confidence interval above. So again, I kind of made reference to that. I'm using that. Now I'm using that for June. So I also, specifically say that that's only for the month of June. And I showed the work for how I got each part. And then I showed how I scaled that for each customer. So that's